So good afternoon, everyone. I'm Steve Zarafa. I'm from, as Joe said, from company PIXAM, a company based on the Maltese Islands. So what do? We do create outdoor robotics. Outdoor robotics, which are used in agriculture mainly, and are built on GNSS technologies. These are some of the robots which we do custom made. Sizes starts from 40 centimeters. The one up there, that tile is 60 centimeters, and they can go up to 2 meters, 3 meters, or even more. And I'm going to divide this session into two sections. The first one, I will be explaining a little bit more in detail about our robots. Then I will explain how Blockly comes into all of this. So, as I mentioned, we do build robotics and GNSS systems, which are quite difficult. If you had to start from a robot and you want to build one, you need to go into embedded systems, you need to go into GNSS, control systems, sensors, mechanical, electrical, networking, different protocols, and everything in between, practically. This creates a very high entry barrier gate, and in fact, you need multi-skilled team. So a person cannot just do one thing, he needs to be able to shift from one thing to another. And because of this reason, most of the companies out there, most of the people who start working on robotics, they switch off after the first robot, generally after a few weeks or after a few months. For us, and this is not only for us because I was discussing with some of the teams over here, it took us years to get the first robot working properly. What do I mean by working properly? At that stage, we were able to replicate what we have done at a scale. So we were able to go from one robot to multiple robots and go to the market. And this literally takes us here. But it shouldn't be like this. Students at university, engineering, ICT, they should be able to use this technology because it's quite useful. It can solve multiple problems. So this is one of our robots. This is a crawler type. It's not four-wheeler, okay? This particular one, we've bought it, and then we've put our control system over there. This is the way you program it because it's GNSS. I will explain about GNSS. You just give it waypoints, and then through the waypoints, it just moves from one waypoint to another. The software that I have showed, it's quite primitive. This robot, this testing particularly was done like 2.5 years ago. Where did we start? We start from IoT systems working in a vineyard. At that particular point, the viticulturist asked us, look, we have these grape trees. We want that you create for us a robot where it would be able to remove the weeds in between the trunks. The weeds in the verticals, not in the horizontal. Why? Because in the vertical, the section is just 80 centimeters. So with big tractors and small trees, normally they have to do it by hand. In fact, what this viticulturist used to do, he used to employ people to remove these weeds, and people were not always available to remove these weeds. And so we started from there, and eventually, when we started building the robots, when we started having all these problems, name it, it was there, mechanical, software, whatever it was, we had a problem. GNSS, you can't count the problems that we had. We said, why don't we try to get something where we could also give it to students, to mature students. Basically, our idea was to democratize the use of robots, of outdoor robots, four-wheelers, or crawlers. So we started building. We selected the main control system, which was the GNSS. Before going into a little bit more detail, I want to explain what is GNSS. Every one of you used GPS with mobile phones. When you use GPS with mobile phones, on a good day, the error margin is 2 meters for a particular spot. On average, it's 5 to 7 meters. On a bad day, especially I live in Malta, there's Sahara Desert coming from all over us. On a bad day, when the Sahara Desert is over there, it goes up to 14 meters. With GNSS, with RTK, you can go up, irrespective of the weather, irrespective of everything, to 2 centimeters error margin. That's it, okay? How do you get to that point? You get to that point by using GPS, the satellites from the United States. You use Galileo, the satellites from European Union. You use Beidou, satellites from China, and you use GLONASS. All constellations, getting the data from all constellations at the same time. Things are a little bit different when you're using GPS. You just get a latitude and a longitude, and that is it. When you're using GNSS, you don't get a latitude and a longitude. You get like plenty of variables in hex in 1 second. And then you need to do the encoding. You need to see what is the data. You need to have a reference, and then you start comparing. And then through all this process, you manage to get to a 2 centimeter position, a position with a 2 centimeter error margin. Why this precision, this amount of precision is important? I mentioned this viticulturalist or others. He required a robot for an area of 80 centimeters. So if you use only GPS, it's an even non-starter, because if you have an error margin by default, which is 2 meters, and you're working on 80 centimeters, that is just not enough. You need something better. So this is the reason why GNSS was better. There are LiDARs, you know about Waymo, you know about other systems, but LiDAR in agriculture, it's again a no-go. Why? Because LiDAR, it has like these optics inside. When you're moving in different soils, different weather, different conditions, stones, whatever it is, LiDAR sensors, which cost around about 15K, starting from 5, going to 15, even more. If something happens to the sensor, one sensor, 15K just goes down the drain. So we needed something more reliable to use in fields. And then we started working with GNSS. If you go to the Gindu.net, there's a dashboard. You can see in real time all the data coming from GNSS. There's a base station transmitting in real time. Okay, and we managed to obtain 2 to 3 centimeters for our robots. So that was all about robots. So what is next? How do Blockly fits in all of this? So when it comes to Blockly, probably we are the new guys in town. So it's not like we're experienced, like you guys, some of you have been working with Blockly for 10 years. So for us, it's quiet and new field, but we're enjoying it. And that's the idea behind it. So the idea started from this. We're building also, so we do build also the boards. So we're building also these IoT boards, okay? This goes on the robot. And through Blockly, what we are doing is that the farmers would be able to switch on different relays. This is a board which could be used with high power devices like pumps, like cutters, or like different things which are used in farming. So we're using Blockly so that the farmers or students or engineer students working with the farmer, they will be able to control a robot, or as we call it, a robotic platform, what it needs to be done, whatever. So if the farmer needs to convert the robot on day 1, needs to do application A, and on day 2 needs to do application B, what he needs just to do is he can use Blockly. He do a program A for a Monday, he do a program B for a Tuesday, and that would be it. Apart from that, we're also at a stage where we're introducing also positioning control. So the robot, if it's in a position A, is able to switch on relay A or sensor A. If it's in a position B, he's able to switch on to position C, relay C, or relay D. So giving control, democratize the use of the robots. So relay control, position control, calendar features, farmers now can control whatever they need to do. How did we do this? Basically, we created a Blockly tool. We found what was available out there. Probably you know about this. There was Arduino Blockly. So what we did is, which was available, which was published by MIT. So we downloaded the Arduino Blockly. we changed the microcontroller because Blockly was made for Arduino. What we did is we converted the Arduino for ESP32. Why ESP32? Because ESP32 has the feature that it could receive data from the Wi-Fi. So if you put the Wi-Fi on your robot, it will be able to communicate directly with the robot. In fact, we also did some tests with using OTA, so that the farmer, there's no need to connect the robot to the system. It just receives the data in real time from our servers, and that would be it. So what we did is we created a map, which is only available for the users who are using our robots. Then you open up the map, you have like the missions, you upload the missions, you have the waypoints, and then again, for each and every waypoint, you can assign a different Blockly program. And this has been on trial for practically 6 to 7 months, but it's moving forward. We have used it with multiple systems. At one point, for example, we used it with a farmer who wanted lights during the evening, because he wanted to do some tasks during the evening, checking the field for particular areas. So he wanted to have like this robot going on and switching on the lights. He used one of these robots with the calendar features. The robot went into site, switching on the lights, take a photo, and coming back. What is our next phase? For us, it was a very good cycle, that we introduced the Blockly. As I said, it's still a learning curve for us, but now we want more. Ideally, now we will also put, this is the idea, this is the vision, we will also put the Blockly for the whole robot. So you will be able to control an outdoor industrial robot, this is industrial robots, by using Blockly, and also by using AI and robot control. So you have you will be able to control the robot. For example, say you move from point A, you get the GNSS position from point A, you move to point B by using Blockly. So this is our target. Something else also that we have introduced late last year is our WUX AI. What does this AI do? Basically, it's able to, in real time, analyze the signal and the signal strengths, which are coming from the satellites. So it's able to see everything is correct, yes or no. Eventually, also, based on this, then the robot is able also to do rerouting. The vulnerable thing about GNSS is that if it comes beneath trees or close to a wall, it starts losing the signal. What does it mean, start losing the signal? Is that from 2 centimeters, the error margin will go up. So if you start detecting these things, then the WUX AI, it can correct and reroute where the robot is moving. It can stop, it can go back, can go to the left, right? Depends on what this WUX AI is building. For us, we've been using WUX AI for quite some time. This was very, very helpful, okay? For us, before, when we used to build a robot, it used to take us days to weeks to calibrate one robot. What does it mean to calibrate it? To move straight, to turn, to get to the correct position, so on and so forth. Now, today, with WUX AI, we're able to calibrate this robot from our office in a few hours, and that's it. Then, just the first run, and the first run, thanks to the WUX AI and the calibration procedure, which is done in the office, it's already there. Eventually, also, the AI keeps on calibrating the robot as it moves. So, why all of this? What is our vision? Our vision is that we have learned a lot. For us, it's been a learning curve of 6 years. We're not really there, we're still learning, but the thing, our vision is this. Other people, we want to democratize this process that by other people will be able to jump on our experience. Why not? Obviously, if they want to jump on our experience, they need to have our boards. But if they jump on our experience, the target is, by using AI, by using Blockly, you will get the parts, you will get everything. In 1 week, 2 hours every day, you will have your own personal robot. Okay, that is it from our side. Thank you. you.